Okay guys, welcome back. So in the last video I explained how the Kirchhoff laws can be inserted when you are given a simple electronic circuit like this. We found the value of I and I1, so we applied the Kirchhoff's laws to the two loops and then found the value of the individual currents that flow through the resistors. Alright, so in this video I will be talking about another application. I will be talking about another simple example in which we can put Kirchhoff's laws, because the way, right, the how much you solve, right, the if you solve 20 problems, and if you compare a student who is solving 20 problems with a student who is solving 8 problems, the student who is solving 20 problems, not 20 similar problems, I am not talking about similar problems, 20 different problems, right, problems that are different from one another, 20 different problems. That doesn't mean the 20, right, a certain value, but I've just taken an example. The more you solve, the more you get, right? So if you solve more and more questions which are not equal to each other, which doesn't mean that you are just changing the resistors and changing the voltages and then solving, so you get more, right, you get practice. So like finding the effective resistance of a circuit, right, effective resistance of a circuit, the Kirchhoff's laws, the application of Kirchhoff's laws is also about practice, right? So the more you practice, more you get. So in this video I'll be explaining about another simple sample problem. Thereafter you can thoroughly understand as to what Kirchhoff's laws hold in current electricity. Alright, let me take another example. So I'll draw the circuit again, draw another circuit. So my next circuit will be like this. Means next circuit is like this, and this is connected to another resistor here. Like this, and this is 20 volts. I'll take the resistance of this to be 6 ohms, here to be 3 ohms, and here to be 4 ohms, and here to be 5 ohms. So I am asking, what are the currents that flow through these resistors? Alright. So as I mentioned in the last video, we'll just take some arbitrary currents that are flowing. So if a current of I is flowing from this circuit in this direction, so it will come to this junction. So from the Kirchhoff's junction rule, or the junction rule, or the first rule, we can say that if a current of I1 flows in this direction, the remaining current, which is I minus I1, will flow in this direction. So the current through this resistor will be I minus I1. So I take the current here to be I2 and the current here to be I3, right? And so the total current that comes to this junction is I minus I1. So the current that should leave from this junction, according to Kirchhoff's junction rule, or the first rule, should also be I minus I1. So the current that goes down here will be I minus I1. So the current of I1 is coming from here, so it will pass this and come to this junction. So again, from the Kirchhoff's junction rule, or the first rule, the current that goes downwards here will be I, and the current that will be arriving to the battery will also be I. Okay. So that is the current distribution across this. So as in the last one, you can take 3 loops here, right? As in the last video, we took only 2 loops. So in this video, we can take 3 loops. So one loop is this loop, the bottom one, this rectangle. The second one is this one, and the third one is this small loop, right? 3 loops. Alright. So I'll just take some arbitrary points: A, B, C, D, E, F, G, H. I take this to be P and Q, because otherwise P, Q and R, right? P, Q and R, otherwise we'll get confused with if I take G, H, I, J like that. I'll confuse the ampere and the current I took with the point, right? Alright. So A, B, C, D, E, F, G, H, P, Q and R are the points that I am taking. Alright. So assuming that there is no internal resistance in this cell, I can put the Kirchhoff's laws. I'll put Kirchhoff's laws in this direction for the bottom loop. So the bottom loop will be P Q R H, right? P Q R H P. So that will be P Q R H P in this direction. So the total electromotive force is 20 because there is no internal resistance. So there will be no energy drop or energy gain due to the voltage. So the total electromotive force is 20. So that should be equal to, since there is no energy drop, you can take the energy drop due to this I. So what actually happens is that there is only one resistance in this loop, and that is the current is in the direction we are putting. So it is positive. So you can take I1 times 5 to be positive. So you can directly find the value of I1. I1 times 5. So if I1 times 5 is 20, I1 is equal to 4 amperes. So we found one directly from 1. So the second way I'll put to the small loop, right? Small loop, the smallest one here. So if I put there, what actually happens is that I can say C, D, E, F, C. In this direction. C, D, E, F, C in this direction. So what actually happens is that the total electromotive force is 0 because there is no voltage supply. So the total electromotive force is 0. And if I put in this direction, I2 is positive. I take I2 positive because I2 is in this direction, but I3 is negative. The voltage due to the current around this one to be negative because this one is in the opposite direction to the direction I am selecting. So it will be I2 times, so 0 will be I2 times 3 minus I3 times 4. So that will be 4I3 is equal to 3I2. This is equation number 1 I am taking. Right, equation number 1, 4I3 equals 3I2. Okay, alright. So if I1 is 4, it will be I minus 4. Alright. So if I put to this loop, to which loop? Right. Okay. So what actually happens is that I can put to this loop, right? Put to this loop here. So what will happen? I'll put is to the H, R, A, B, F, E, G, H. It's a huge loop, right? Huge loop. I'm taking the endpoints. So to this loop, what actually happens is that the total electromotive force is again 0. So this will be positive because I am taking in this direction. So this current will be this current I minus I1. I have to take the voltage this to be positive, but this to be negative because I am putting in the opposite direction. Okay. So that will be I minus I1 times 6 minus plus I3 times 4 minus I1 which is 4 times 5 is 20. So again here is 4, right? I minus 4. So here is 20. You can cancel 2's from here. 3, here will be 2, here will be 10. So 10 is equal to 3I minus 12 plus 2I3. Right? So plus 12 is going to this side, so that will be 22 will be equal to 2I3 plus 3I. right? So this is equation 2. So I will put again this one to the next loop, right? I will take the same points here, but I will now put to this loop, taking this loop. So for R A, right? R A B C D G H and R, right? To the top one. Only I put to this loop, downwards here and then completing, and now I'll put to the top loop here, upwards and completing. So R A B C D G H R. So again it will be a large loop. So the total electromotive force is again 0 because there is no potential supply. So this I minus I1 will be positive. So I1 is 4, so I minus I1 is I minus 4. So I minus 4 is positive, and I2 is positive because we are putting in this direction, and again I1 will be negative because we are putting in the opposite direction. Alright, so that will be 0 equals 6 times I minus I1 plus 3I2 minus 5I1, right? So that will be, this will be 4, so this will be 20, here will be minus 24, so minus 24 minus 20 is 44, that will go in this here, 44 is equal to 6I plus 3I2, right? But I know I2, 4I3 to be 3I2, so if 4I3 is 3I2, 3I2 is again 4I3, so I can substitute that here, 4I3. So 44 is equal to 6I plus 4I3, so that means you can simplify that, 22 equals 3I plus 2I3. This is equation number 3. So what actually happens, you will get 2I3 here, 2I3 here. So what actually happens is, I'll subtract that, and then you can find, I will not find here, what actually happens is that you can find the values of I1, I2 and I3, right? So I will not solve this because I will leave it to you, right? I will leave it to you as to what happens when you solve that. So you can find the values of I1 you already found to be 4 amperes, I2 and I3 like that. So that's another example in which we can find, we can apply, or we can insert the Kirchhoff's laws in complex circuits. So this will probably be the last video on Kirchhoff's laws and Kirchhoff circuits. So see you next time with a new topic. See you then.